So this revolution in biotech, we can compare it with the revolution in the computing world, but with one difference. Most of the success of biotechnology came from the true academic labs, as compared to the computing world where independent entrepreneurs or the people who were college dropouts or students ultimately developed. People like Mark Zuckerberg, who developed Facebook, or Bill Gates, who did Microsoft, or Larry Page or Sergey Brin, who did Google, or Janis Fries or Nicholas Sandstrom, who made Skype. These were all independent entrepreneurs. But in biotech world, we had proper academicians, professors who ultimately made these companies. Um, so we discussed Genentech earlier, and Genentech was very successful. Ultimately, it was acquired by Genentech, by Roche, which is a big pharmaceutical giant, for $46.8 billion. Currently, it has around 13,000 employees, and it has 19 breakthrough biopharmaceutical products. The academician behind it was Dr. Herbert Boyer from California, Berkeley. And this was the guy who brought in restriction endonucleases. Similar to Genentech, one company which made a huge uh, hallmark on the biotech world was Amgen, which was termed as Applied Molecular Genetics, but later it changed its name to Amgen. At the moment, this company has around 11 breakthrough biopharmaceutical products, but actually with more employees than Genentech, around 18,000. And it has revenues around $20 billion, with total assets around $70 billion and a net income of $5 billion. So the academician again behind Amgen was Dr. Winston Seltzer from California, Los Angeles. And they developed the first drug to basically cure anemia, erythropoietin, first recombinant erythropoietin. Similarly, another company, Biogen, with 10 breakthrough biopharmaceutical products, with a revenue around $9.7 billion and total assets of $15 billion, with the current employees around 7,500. So they come up with very innovative drugs as well. One of the drugs which I have shown here is Tisabri, natalizumab, which is a monoclonal antibody which binds to your blood-brain with an endothelial receptor in blood-brain barrier. People who have multiple sclerosis can be cured by this drug. So what happens in multiple sclerosis? आपके ब्लड ब्रेन बैरियर के ऊपर कुछ रिसेप्टर्स हैं जिनकी हेल्प लेते हुए वाइट ब्लड सेल्स ब्लड ब्रेन बैरियर क्रॉस करते हैं एंड दे स्टार्ट टू ईट द माइलिन शीथ ऑन योर न्यूरॉन्स. बेसिकली न्यूरोनल फाइबर्स को एक माइलिन शीथ इंसुलेट करती है और ये वाइट ब्लड सेल्स जाते हैं और उसको फौरन समझते हुए अटैक करना स्टार्ट कर देते हैं एंड दे पर्टिकुलरली ईट अवे दैट माइलिन शीथ. एक पाकिस्तान की टॉप मॉडल को भी मल्टीपल स्क्लेरोसिस है. तो Tisabri, what it does, it goes on and sits on those receptors and ultimately blocks the way of white blood cells के वो blood brain barrier cross ना कर सकें और ultimately वो शीट ना खा सकें. Academics behind this particular company was Kenneth Murray from Edinburgh, or Charles Weissman from Zurich University, and Philip Sharp from MIT. Here in the picture, you can see that he is receiving a prize. Now, Genzyme. Genzyme was different from the rest. Why? Because it targeted a niche market. It targeted a market for which there was not many people, but basically, if you don't have a lot of people for a particular disease, we call them orphan diseases. Most of the companies don't target such diseases because there is not a big market for it. So there are people in this world who have what we call Gaucher disease. I'll explain that disease in a bit. But Genzyme at the moment have around 16 innovative biopharmaceutical products and revenues around $5 billion. Now, they came up with this drug known basically an enzyme which could cure Gaucher disease. So what is Gaucher disease? It is a genetic disease in which fatty substances, particularly a sphingolipid named ceramide, gets accumulated in your cells and certain organs. और ये क्यों होता है? It happens because there is a hereditary deficiency. जो एंजाइम एक ग्लूकोसेरिब्रोसाइडेज एक एंजाइम है जो बेसिकली आप में सिंथेसाइज नहीं हो रहा होता. तो इफ़ यू स्टार्ट टू गिव दैट एंजाइम ओरली or by injection, ultimately you can start to cure this disease. What are the symptoms? Basically, there is a low blood platelets, जिसकी वजह से you get bruising, anemia, fatigue, and ultimately enlargement of the liver and spleen as well. So, prior to their genetically engineering of this enzyme and trying to and basically producing it outside the human body, people used to collect around 22,000 placentas to treat Gaucher patients, so that they, because from placentas are ultimately thrown when the birth is happening, so ultimately you can collect this enzyme from placentas. So you can imagine कि कितनी ज़्यादा fatigue ख़त्म हो गई by this particular product. So the academician behind Genzyme was Dr. Henry Blair, who was a research technician at Tufts University. In the next topics, we'll also see that what companies came out after 2000's debacle and what products they brought to the market.